Welcome everybody in AP Chemistry series. Today we will complete the videos of Unit 7 and we're going to cover section 7.6, the properties of the equilibrium constant. I will start with rules immediately without taking so many things before. So rule number 1 says, when a reaction is reversed, K is inverted. What does this mean? If you look at the two equations down below, the first one, we have reaction of A plus B with a corresponding value of Kc, which is given to us, it's 3. And we have another reaction that is actually related to the first one, but the Kc value is unknown. So how can I calculate the value of the unknown value here? Okay, first of all, you have to look at what is the difference between the two equations in here. You can see that equation number 2, which is your target, is the same as the first one, but it is inverted. If you look at the reactants AB, okay, they are products in the second equation, which means that totally the equation is just like flipped or it's reversed. Since the first one is inverted to be the second one, then what should I do for the value of Kc in order to calculate it for the second reaction? The rule says if it's reversed, then the K value is inverted. So what does it mean? It means that you have to take the reciprocal of the Kc. Okay, so if you flip the equation, you have to take reciprocal of Kc. So the value is going to be 1 over Kc. So it's going to be 1 over 3 for the unknown reaction. Okay, rule number 2 says, when the stoichiometric coefficients of a reaction are multiplied by factor C, K is raised to the power C. So I just want to give an example. The same one, A plus B gives us C with the value of Kc. It's going to be 3, okay, guys? Okay. What happened to the value of Kc if we have the same reaction, but the values are multiplied by factors? For example, it's 5A plus 5B, and we have 5C. At that point, let's go again to the rule. It says the stoichiometric coefficient of reaction are multiplied by factor C. The factor here is 5, as we can see, right? It's 5. Then K is raised to the power C. So the factor here is 5. Then the value of Kc will be raised to the power 5. So at that point, Kc is equal to 3 to the power 5. Why it's 5? Because the coefficient that I multiply the whole equation is equal to 5. Now, pause the video and read the question carefully. Okay, I will start with B because it's related to our lesson. The question says the equilibrium constant Kc for this reaction. You know, like you have a value of Kc that is given to you, the first one, okay, you can see with its corresponding value of Kc. The question is asking me, how can I calculate the value of Kc for this reaction? The first thing that you have to keep in mind, this is the given, okay? So I have to work in this given value in order to manipulate the first equation to be the same as the second one. So I want to change 1 to be 2. Okay, so if you look at the first equation, number 1 and number 2, I need to change 1 to 2. So you can see that the first step for number 1 is to flip it. So I have to say it's Cl2 plus, we're going to flip this guy in here, plus 2NO, and then NOCl. Now, if you flip it, then what happened to the value of Kc? The value of Kc, according to the rule, has to be in a reciprocal form. So you have to say it's 1 over 2.4 times 10 to the power negative 7. But if you look at this equation, if you look at this and the green one, are these the same? My target is to change the first one to be the same as the second one. But we can see no, we have some differences between them. We can see it's multiplied by a coefficient of 1 over 3. Okay, so if I multiply the whole equation by a factor of 1 over 3, then it's going to be 1 over 3 Cl2 plus 2 over 3 NO, 2 over 3 NOCl. If you multiply by coefficient 1 over 3, then the coefficient will be raised as a power. If you just remember, you have 1 over 3, 1 over 3, 1 over 3. So it's going to be the same answer in here, 1 over 2.4 times 10 to the power negative 7, but it's going to be raised to the power 1 over 3. In other words, you're going to take the cube root for this equation. And if you do this process in your calculator, you will end up with this answer, which is 160.2, which is the same one as this answer in here. Okay, guys, you can pause the video and read the question carefully. The question says, what is the numerical value of the equilibrium constant Kc for the reaction? Where is your target? Here is your target. Okay. If the equilibrium constant for this reaction is given, okay, so your idea or the only target here is going to change the known value, which is the given, manipulate the given value to be the target one. So where is the target? Here it is. Okay, I need to change the equation down below to be the same as the one above. All right, so first look, what can I do to the given equation in order to make it the same as this guy in here? You can notice that the first thing that is flipping, because you can see that the NO is in a product and the target, but it's in the reactant and the given one. So I have to take the given one and just flip it. Okay, I will take this guy in here. Okay, I flip you. You become O2 plus N2 and 2NO. If you flip it, then you have to take the value of Kc and then flip it again. So it's going to be 1 over 3.5 times 10 to the power negative 6. Okay, now we have to check. Do I have the same equation above right here? You can notice that, okay, the NO is in product is the same as this, but the coefficient is not the same. What is the coefficient that I have to multiply this equation to be the same as the one above? It's number 3. If you multiply the whole equation by 3, then it's going to be 3O2 plus 3N2, 6NO. All right. So at that point, you have to say, okay, the Kc value, you take the reciprocal because it's a flip, negative 6, and it's multiplied by 3, okay, and it's raised to the power 3. If you do this process, you will end up with this answer, which is 2.3 times 10 to the power 16, which is the same guy in here. Let's take the last example. The question says, what is the numerical value of the equilibrium constant Kc for this? So the first one here is your target. I need to change the given one to the target. This is the given. I need to change the given into target. So how can I change this equation to be the same as this guy in here? You can see that the first process, the SO2 is in reactant side. The SO2 is in a product side. So I have to change the given to be flipped. Okay, then it's going to be SO3. Okay, it gives you SO2 plus half O2. The value of Kc is going to be flipped. So it's going to be 1 over 2.7 times 10 to the power negative 3. But we didn't finish. Is this one as the same as the target? No, you can see that it's multiplied by coefficient 2. So I have to say my whole equation must be multiplied by 2. So if you multiply it by 2, it becomes 2 SO3. You have 2 SO2 plus 2 times half is equal to O2. So it's the same as the target one, if you can see. Okay, it's the same as this one. So I have to say, since you multiply it by number 2 or coefficient 2, then it should be raised to the power 2. And if you apply this processing here, you will end up with this answer. Okay, guys, until this point, we're done. Let's complete part 2. Stay tuned.